Right, so what we're going to have here is we're going to go through a thing called the collision theory, which basically says why things react. What I've got here are two types of calcium carbonate. One's marble chips and one is a crushed powder. Chemically, they're the same thing, but we're going to observe their reactions with hydrochloric acid to see that there is actually a subtle difference. So I'm going to put some hydrochloric acid in each test tube, and now we're going to have a look at what happens when we put some marble chips in there. And we can see that it starts to bubble, which one is a sign of a reaction occurring. Okay, and if we were to test that gas, we would find that it's carbon dioxide. So we've got that reaction happening there. Take note of how quickly that's happening, so the rate of reaction, because the collision theory is all about what makes, why do things react, but also why do they react the speed they do. Now I'm going to take about the same mass, we'll see what happens here if I take it roughly the same mass as a powder, which would be a decent spatula full. So that's probably about the same mass as we had. I'm just going to stand back a little bit on this one just in case, and we can see that it's going a lot faster. So if I put the two next to each other, there's a real reaction difference, even though I've used about the same mass and about the same volume, and the two acids with the same concentration. Alright, so we want to know the reasons for that, and this is a thing called the collision theory. So I'll just quickly go through what that is up on the board for you. Okay, so the collision theory basically states that for a chemical reaction to occur, you must have reagents that can react. And we've got that, calcium carbonate and hydrochloric acid. So the reagents or chemicals must be able to react. With each other, of course, is what I mean there. Okay? So that's the first thing that's really important. The second thing is that they must actually collide. They actually have to meet each other. If I put the marble chips in one test tube and the hydrochloric acid in the other, no reaction is going to occur because they've never met each other. They actually have to collide. So the reagents have to collide. Then we have a look at, so they collide, big deal. There's actually particles in here that are colliding that are not actually reacting. They will eventually, but there's collisions in there that are doing nothing. And the reason for that is because of the way they're colliding. The analogy I like to give is Lego. You can only put Lego together certain ways. The inny bits click to the outy bits. If you try to put them together other ways, they don't tend to work. This is what we call orientation. They have to collide in the correct orientation. So if you try to put them together the wrong way, they just bounce off each other. Alright? So collisions must be in the correct orientation. And the last bit that's important for this is, again, I like the Lego analogy. It's all well and good to put two bits together facing the right way, but if you don't push them together hard enough, they don't stay together. So they have to collide with enough energy. So particles must collide with, so collisions must have enough energy. And we normally call this the activation energy, but it's not just that. So in a nutshell, that's your collision theory. What you're going to be investigating in the next week is what factors you can change in this reaction to change the reaction rate. What factors will make it go faster or slower? What can you do to make it go faster or slower? And how does that affect each of these, if at all? If it affects even one of these, it will affect the rate of reaction. All right? And things that we're going to investigate are concentration, surface area, temperature. There's also another one, and that is a catalyst. But we haven't got a catalyst for this reaction, so we're not going to be investigating that one. So I'll put that just over to the side. Now I'll just quickly explain to you what a catalyst does. A catalyst is something that you can put in a reaction to speed it up by it basically draws in the reagents and lines them up correctly. So it gives them an alternative pathway, which means they need less energy for the collisions because they're already lined up correctly. So it means you're going to have more successful collisions because they're already aligned properly, or they already have the correct orientation. Alright? But I'd like you to investigate all three of these over the next week and link it to what effect does it have on any of these ideas here. Alright?